Hello everyone and welcome to the second part of this training, which will cover an introduction to Azure Storage services, how to create and configure storage accounts, manage access keys, manage data, configure replication, and understand the principle of shared access signature. Just to remind people who are here for the first time, this is part 2 of 5 of the AZ100 for Azure Administrator course, which you can only find on this channel. Initially, I would recommend you the first part of this course to understand some general notion about Azure, after which you can return to this part. In the description of this video you will find all useful links related to this course, as well for the first episode. I want to mention also that this part will cover about 10 demos, and for any question don't hesitate to ask via Facebook group. The link as well will be placed in the description. Now take a coffee and enjoy the session. As I said, let's begin with an introduction to Azure Storage, that is a Microsoft managed cloud storage service offering solution to today's all storage problems. It is a massively scalable object store for data objects, disk storage for Azure virtual machines, file system service for the cloud, and other objects. Azure Storage Platform includes features like durable and highly available. This means that redundancy ensures that your data is safe in case of hardware failures. You can also opt to replicate data across data centers or geographical regions, but we'll talk later about. Security. All data written in the storage account is encrypted by the service. Scalability is designed to be massively scalable to meet the data storage and performance needs for today's applications. Manage. You don't need to handle hardware maintenance, updates, and critical issues. Azure will take care to perform these tasks. Accessible. Data in Azure Storage is accessible from anywhere in the world over HTTP or HTTPS. Also, you have client libraries for Azure Storage in a variety of languages, including .NET, Java, Node.js, Python, PHP, and many others. Somehow it gives you a flexibility to develop an application in the cloud and use Azure Storage. There are few platforms includes the following data services where you can storage your data, like Azure Blobs allows you to store unstructured data and access at a massive scale in block blobs. Azure Files offers fully managed cloud file shares that you can access from anywhere via SMB protocol, and it is capable of replacing file servers in your infrastructure, but we will discuss this later. Azure Queues, a messaging store for reliable messaging between application components. And the last one, Azure Tables, that allow you to store structured NoSQL data in the cloud. So let's talk about each service storage platform in particular. Azure Blob is an object storage solution for the cloud optimized for storing massive amounts of unstructured data, such as text or binary data. It is ideal for serving image or documents directly to a browser, storing files for distributed access, streaming video and audio. It is also used to store data for backup and restore disaster recovery. Already mentioned this, that objects in Blob Storage can be accessed from anywhere in the world via HTTP or HTTPS, and API as well is applicable to work with a storage account. The next service is Azure Files. Enable you to set up highly available network file shares that can be accessed by using SMB protocol. That means that multiple VMs can share the same files with both read and write access. You can also read the files using the REST interface of the storage client libraries. One thing that distinguishes Azure Files from files on a corporate file share is that you can access the files from anywhere in the world using a classic URL that points to the file that includes a share access signature token, but we'll talk later about. If we list a few scenarios for Azure Files, first will be applications that use file shares. With Azure Files, makes it easy to migrate to those applications that share data to Azure. configuration files that can be stored on a file share and accessed from multiple VMs. And the last one, you can upload to file share resource logs, metrics, and use it when needed. Okay, Azure Queue Data Service. It's used to store and retrieve messages. I think it's hard to imagine now, because that was happened to me. I was confused too. Let's assume that you have a blog and some pictures are uploaded on each post, and you want to create thumbnails for each picture. So Azure Queue Service can help you with this. Then have an Azure function retrieve the message from the queue and create the thumbnails. Each of the parts of this processing can be scaled separately, giving you more control when tuning it for your usage. Of course, if you have a blog with 100 pictures, my example is not the best, but in social media, when you have millions of users, this kind of architecture is applicable because queues are generally used to store lists of messages to be processed asynchronously, and the message size can be up to 64 kilobyte. The next one, Azure Table Storage, is used to store large amounts of structured data. This service is a NoSQL data store which accepts authenticated calls from inside and outside of Azure Cloud. Azure Table is perfect for storing structured and non-relational data. Table storage can be used for structured data coming or used by web scale application. Also can be used to store datasets for fast access, querying data using a clustered index, and accessing data with .NET libraries. Okay guys, we have discussed Blob, Azure Files, Queues, and Table Storage, and all these data objects are incorporated in a storage account. If you want access to one of these data services, you will need to deploy a storage account. When you create a storage account, you will have to choose the account type. Each type supports different features and has its own pricing model, and you need to consider these aspects below before deploying which account is best for you and best for your applications. The first consideration is account type. You have general purpose version 2. It is a basic storage account type for blobs, files, queues, and tables. This account is recommended for most scenarios using Azure Storage. General purpose version 1, an account type as well for blobs, files, queues, and tables. Basically, this is a version 2 legacy account, but this version does not support access tier, zone redundant storage, and other features. So Microsoft recommends to deploy version 2 instead of version 1. Blob storage accounts with premium performance characteristics for block blobs and appended blobs. It's recommended for scenarios with high transaction rates or scenarios that use smaller objects or require consistently low storage latency. The next one is file storage accounts. This type of storage accounts as well have premium performance characteristics. It's recommended for enterprise or high performance scale applications. And the last one, blob storage accounts. Legacy blob only storage accounts. As well, Microsoft recommends to use general purpose version 2 accounts instead of this when it's possible. If we talk about performance, Azure offers a standard and premium performance tier for storage accounts. A standard performance tier is for storing blobs, files, tables, queues, and Azure Virtual Machine disks. Premium performance tier is for storing and manage virtual machine disks. File storage as well is using a premium performance tier. I prepared a diagram for Azure Storage application over a few slides that includes the account type, performance, and replication options. And I'm sure you will understand what accounts are using standard and premium tiers. Nowadays, storage systems have different algorithms for accessing data based on usage pattern. In Azure Storage, each access tier is optimized for a particular pattern or data usage. By selecting the right access tier for your needs, you can store your block blob data in the most cost-effective way, for example, hot, cool, or archive. We will return to this subject later. At this moment, Azure Storage offers 6 types of redundancy that can provide you high availability for your data. As well, for this storage feature, we have a separate slide and we will pay more attention to all redundant options. Encryption. All data in your storage account is encrypted on the service side, and you cannot disable it. Because your data is secured by default, you don't need to modify your code or application to take advantages of Azure Storage encryption. If you want to have a custom encryption, you can use Azure Key Vault to keep your encryption keys in your environment. Endpoints. Every object that you store in Azure Storage has an address that includes your unique account name. The combination of the account name and the Azure Storage Service endpoint is forming the endpoints for your storage account. For example, if your storage account has SA name, the parts with orange, then the default endpoints for that account looks like on the right on this page. For Blob Storage, you will have SA name, .blob.core.windows.net. Respectively, for the table, you will have storage account name, .table, and so on. In terms of control access to account data, you can control access with Azure AD, short K, and SAS to authorize requests to the storage account. In terms of cost, you will be billed for Azure Storage based on your storage account usage. All objects in a storage account are billed together as a group, none in particular. Below you can see the factors used to calculate the storage cost. We have region, account type, access tier, storage capacity, replication, transaction, and data egress. Okay, this is a general overview of storage account. In the next slides, you will see in detail each part, how to configure and use it. To create a storage account in Azure Portal is not rocket science, and you can do this via Portal, PowerShell, or Azure CLI. When a storage account is created, you have some fields that are required, like a resource group, storage account name, and so on. The name you choose must be unique across Azure, not just in your subscription. The name also must be between 3 and 24 characters in length and can include numbers and lowercase letter only. Basically, all the parameters we have learned in the previous slide, location, performance, replication, access tier, and so on, you will need to configure before deploying the storage account. In this slide, you have a few examples of how to create and delete a storage account, so let's switch on Azure Portal for a demo. You already know that a resource can be created from the left menu, create a resource link, or navigate to the service directory as I did. Click on Add, and this is the first tab where we need to define subscription, then the resource group. Next step is to complete fields like a storage account name. Here I have to remind you that the name must be unique across all existing storage account names in Azure, not just in your subscription or directory. Use only lowercase letters and numbers. Next step is the location, the data center where your storage account will be deployed. Performance, we already discussed this option. The premium storage will offer consistent and low latency performance, and a good SLA better than the standard option. As well, the performance is directly related to replication and access tier. As well, account kind, depending on what you choose here, the replication option will be populated with a respective replication type. On this point, you will better understand when we will discuss the replication option in detail. Okay, I will choose a standard account kind version 2. Replication will leave as default. Network tab, here you can configure to permit or deny access at network level to your storage account, but we will return to this part in the next slide. Data protection tab, from which you can configure options like soft delete. If you delete some data by mistake, you have the option to recover. Just set the number of days to freeze your deletion. In Advanced tab, you have a few options to secure or not to secure your storage account, to use HTTPS instead of HTTP, public access, TLS versions, access tier to choose between cool and hot. The archive option is not available here because it's configured at blob level. Okay, apply the tags for your resource, review the settings and click create to deploy the storage account. After deployment, go to resource, and here you have an overview of your storage account, a basic information about status, location, subscription ID, tags, performance, access tier, replication, account kind, and that's it. Below you can access the containers, SMB file shares, tables and queues. Here you have monitoring section and you can choose to show data from the entire account or for specific data service. Activity logs, tags if you want to add or delete new values. Here you can explore the common problems that you can encounter with the storage account. Access control used to add a role who can manage this storage account. Storage Explorer to preview the content. In settings you will find the access keys and connection string to your storage account used for authentication. A preview of how your data is replicated. Configuration tab if you want to modify something, for example access tier. Encryption tab, so in any case your data is encrypted, and if you are using Microsoft managed keys you don't have access to that keys. If you want to manage the keys, you will need to deploy a key vault, then use the key to encrypt the storage account. Shared access signature, we will have a separate demo on how to work with this feature. I will not go into details now. Network tab, then below you have separate tabs for each data service, blob, file, table and queues where you can access your data. Monitoring tab, where you can see in detail the performance for the storage account, automation and support in case if you have an issue and somehow you cannot solve that problem. Again, this presentation of the storage account was an overview. We will go deep for the most important feature in the next slides. Now let's create a storage account from Azure CLI as I promised in the objectives of this demo. In the top right side you will find a shortcut to Azure Shell. If you have never connected to Azure Shell, you will be asked to create a new storage account for mounting the Azure Shell session. Click create and wait to open the session. Well, once your CLI is opened, you can choose in what syntax do you want to work, PowerShell or Bash. Maybe you are more familiar with Bash. I will choose PowerShell. To create a storage account in PowerShell, use new AZ storage account command. As syntax, the first parameter is resource group name. If the resource group is not created, first you'll need to create it. Account name, location, replication parameter is SQ name, and add the replication. Basically, these are the main parameters to create a storage account, and press enter to deploy the account. If you want to get the storage account list from your subscription, use get Azure Storage account. For specific account, use name parameter and resource group. And that's it. Thanks for watching. From the previous demo, you have seen that there is a network tab on storage account deployment. From there you can secure and control the level of access to your storage account based on the type and subset of networks used. When you apply network rules, only application requesting data over the specified set of networks and can access a storage account. You can limit access to your storage account to requests originating from specific IP addresses, IP range, or from a list of subnets in an Azure virtual network. Well, the security rules are not applied to the net or subnet. but a subnet can be associated with a network security group. Then you can add inbound and outbound security rules. A good approach to secure your storage account is to configure a rule to deny access, to deny traffic from all networks, including internet traffic. Then you configure the rule that grant access to traffic from specific VNet and point to your storage account. You can also configure rules to grant access to traffic from public internet IP address ranges, enabling connection, for example, with your local data center or branch office. As limit, you can add up to 100 virtual network rules, and you can combine firewall rules that allows access from specific virtual networks and from public IP addresses ranges on the same storage account. Let's see a demo on how to configure network access for the storage account that we already created in the last demo. Basically, you can do the security configuration of a storage account on network level during deployment and post deployment. To do this, go to a storage account that you want to secure. In Settings, Firewall and Virtual Networks tab, we will choose to allow access to our storage account for specific networks. I will click on Add Existing Virtual Network because I already have a virtual network. We'll choose the net1 and the subnet, then enable and add the subnet. As well, from here you have the option to allow access from the internet for one IP address or address range. As an example, I can use this one. Below, a few exceptions if you want to allow Microsoft services to access your storage account. Networking routing to redirect your traffic is depend on what requirements you have to redirect traffic to the Azure Storage endpoint or requesting client. That's it, thanks for watching, and let's move to the next topic. In the storage overview slide, we already mentioned that there are few different ways you can delegate access to a storage account, and one of them is shared access signature SAS that grants restricted access right to Azure Storage resources. This type of access refers more to external use, I mean outside of the cloud, and you have granular control over how a client can access your data and what resources, what permission they have on those resources. You can set start and expiry date for each generated token. Azure Storage accounts support three types of shared access signature. The first one is user delegation SAS that is secured with Azure Active Directory credential and also by the permission specified for the SAS. This combination of Azure AD plus SAS applies to a Blob Storage only. The second one is service SAS that is secured with the storage account key. A service SAS delegates access to a resource in only one of the Azure Storage services like Blob Storage, Queue Storage, Table Storage, or Azure Files, not for all at the same time. And the last one, account SAS, is used to delegate access to all four storage services, Blob Storage, Queue Storage, Table, and Azure Files. Basically, it's easy to remember. Service SAS used to access a specific data service in a storage account, and account SAS used to access all data services in a storage account. All these types of shared access signature are signed via URI that points to one or more storage resources and includes a SAS token that contains a special set of query parameters like validity time, permissions, protocol, IP address, signature, type of resource, and so on. If this URI is leaked, you could be in trouble because your storage account could be compromised, and to avoid these leaks, every time follow the best practice. And let's see a few recommendations for using shared access signature that can help you to avoid the risks. Use HTTPS to create or distribute a SAS. If you are using HTTP, it's easy to be intercepted, and an attacker is able to read the SAS and then use it to access your data. Use a user delegation SAS when it's possible because it is more secure. have a revocation plan in place for access. Make sure you are prepared to respond if access is compromised. Define a store access policy for a service. As well, store your access policy gives you the option to revoke permission for a service without having to regenerate the storage account keys. Be careful with SES start and end time. Let's see how it's done in real life. Okay, we have a separate tab to generate SES, and it's beginning with the services which you want to permit the access: blob, file, queue, and table. Then you have resource type to permit access at container, service, or object level. Okay, next step is to select the permission to read, write, list, create, and so on. Blob versioning. Then we have the start and end date that will help you to provide a time frame for this SES. To limit access at the network level, you can specify an IP address here, and it doesn't matter if the SES will be used by a person or application. What is important is that other requests will be denied. Select the protocol that will be used during data transfer, then select with what key do you want to generate the SES, and click Generate SES and Connection String. Below you have the connection string, the SES token, and the URL for each service: blob, file, queue, and table. Another way to generate the SES is to do it directly on blob. Again, choose the signing method, key, permission, start and end date. But before generating, let's try to access this blob via URL. And as you can see, the access is denied. Let me come back to the main tab and copy from here the SES token, then paste it after the URL of this blob. The advantage of generating a SES directly on a blob: you will not expose the entire storage account but specific file. That's it. Thanks for watching. For any question, don't hesitate to ask via Facebook group. The link is presented in the description of this video. Okay, let's move on to the most important aspect of a storage account: access keys. When you create a storage account, Azure generates two 512 storage account access keys. These keys can be used to authorize access to data in your storage account. Microsoft recommends generating these keys every 3 months, and maybe you already figured out that this is not a good approach when you have 100 storage accounts and maybe 50 applications that need to be updated when you regenerate the keys, because the connection will be lost. Well, Azure Keys Vault can help you in this way to manage your access keys and regularly rotate and regenerate your keys. Key Vault is used as well to avoid any kind of compromised situation, because your storage account access keys are similar to a root password for your storage account. So always be careful to protect the keys. As I said, Azure Key Vault can manage and rotate your keys securely. As well, avoid distributing access keys to other users, hard-coding them, or saving them anywhere in plain text that is accessible to others. Depending on your design, if it's possible, use Azure Active Directory to authorize requests to blob and queues storage instead of shared keys. So let's see how to work with access keys. Use a key vault to manage the storage account keys and enable auto regeneration in the next demo. The objective of this demo is how to manage storage account access keys via key vault resources. First of all, we will create the key vault resource, and this time we'll create via CLI because some parameters are not available on the portal side. Okay, to create a key vault, you can use a new AZCopy command and a few parameters like vault name, resource group name, and the location. After key vault is deployed, we will create a new storage account to link one of the key to key vault created 1 minute ago, with the scope to regenerate this key automatically every 10 days, for example. So let's define first a few variables that will help us later to activate the regeneration period for storage account keys. Storage that will be used to extract the storage ID, then we will need to get the Key Vault application ID, and this can be done by using getAZAD service principal. Better to add the display name like Azure Key Vault, and from this get we have application ID and ID. Basically we need just the ID that will be used later. Okay, now we need to assign a storage account key operator service role for the Key Vault, and we will use the service principal ID, the role, and the scope, the storage ID from the first variable that we defined earlier. Okay, next is to define the user principal ID variable that will be used for Key Vault access policy, regeneration period variable, and the last command, add AZCopy managed storage account. The first parameter is vault name, then storage account name, account resource ID. This parameter is referring to the storage account resource ID and can be found in properties of storage account. Active key name, one of the storage account keys, and regeneration period variable. Now let's have a look what we have done here. So we have a vault name and storage account. The first key for the storage account, we have auto-regenerated key on true and regeneration period for 5 days. This means that Key Vault will change the K1 every 5 days. So this was the objective of this video, to understand how to manage storage account keys in an effective way, and if someone asks how to access the storage via Key Vault, so you will need to create a secret, and the secret will be used to access the storage account services. For any questions, don't hesitate to ask via Facebook group. The link is presented in the description of this video. Thank you. Well, the next topic is replication. Azure Storage always store multiple copies of your data to protect from planned and unplanned events, including transient hardware failures, network or power outages, and of course massive natural disasters. Redundancy ensures that your storage account meets the server level agreement for Azure Storage even in the face of failures. When deciding which redundancy option is best for your scenarios, consider the trade-off between lower cost and higher availability and durability. The factors that helps determine which redundancy option you should choose include how your data is replicated in the primary region, whether your data is replicated to a second location that is regionally distant to the primary region to protect against regional disasters, and whether your application requires read access to the replicated data in the secondary region if the primary region becomes unavailable for any reason. So let's take them one at a time. For example, in the primary region, the data is always replicated 3 times. Basically, Azure Storage offers 2 options for how your data is replicated in the primary region: locally redundant storage and zone redundant storage. Locally redundant storage replicates your data 3 times within a single physical location in the primary region. LRS provides at least 11/9 durability of objects over a given year. It is a lower cost redundancy option and offers the least durability compared to other options. Local redundant storage can be used in scenarios like application stores data that can be easily reconstructed if data loss occurs. You may opt for LRS. Or if your application is restricted to replicating data only within a country or region due to data governance requirements, you may opt also for this option. If we are talking about zone redundant storage, your data is replicated synchronously across 3 Azure availability zones in the primary region. This means that you have 9 copies of your data, 3 per zone. Each availability zone is a separate physical location with independent power, cooling, and networking. You can use zone redundant storage as a primary region for scenarios that require consistency, durability, and high availability because it has low latency and resiliency for your data if it becomes temporarily unavailable. Okay, if primary regions redundancy option may not protect your data against a regional disaster where multiple zones permanently affect, you can opt for redundancy option in the secondary regions that as well has two options for data redundancy. First one is geo redundant storage and second geo zone redundant storage. The primary difference between geo redundant storage and geo zone redundant storage is how data is replicated in the primary region. Within the secondary location, data is always replicated synchronously 3 times using LRS. We also have read access for geo redundant storage and read access geo zone redundant storage. When you enable read access to the secondary region, your data is available to be read at all times, including in a situation where the primary region becomes unavailable. Because it is not easy to visualize how replication is available for each storage account kind, I prepared a diagram that will be very easy to understand. For example, for premium storage account, you have just local redundant storage and zone redundant storage. But again, it's depending what storage data service you will choose, or standard storage account version 2 that have all replication option. Okay, let's come back to the storage account that was created a few demos ago, and let's try more attention at the replication options. Okay, when you access a storage account, in the overview tab you can see the current replication option used for the storage account and the account kind, because as I said, the account kind is directly related to the replication type. If you want to change the replication for the current storage account, you can do it from settings and configuration tab. Select the new replication type and click save. A view on the map of how your data is replicated, you can see it on the geo replication tab, the primary and secondary data center. And to confirm the diagram from the presentation, let's try to deploy a new storage account. As you can see, depending on account kind and performance you choose, you will have different replication options. For example, premium account with version 2 account kind will have just local redundant storage, and premium file storage account also zone redundant storage. Hope this demo was quite clear to you. The purpose was to familiarize you with all replication options. Now let's move to the next topic. Azure Storage supports authentication over SMB for Azure files. This process is using Kerberos protocol for authenticating with either on-premise Active Directory or Azure AD. When an identity associated with an user attempts to access data in Azure file shares, the request is sent to the domain service. This could be a classic ID from your on-premise environment or Azure AD to authenticate the identity. If authentication is successful, it returns a Kerberos token. Then the client sends a request with this Kerberos token, and Azure file share use that token to authorize the request. Well, as a prerequisite, you need to create Azure AD directory on your subscription to enable Azure AD domain services. As well, the devices that you will access the Azure files need to be domain joined. As final action, you will need to create the Azure file share and mount the share on the devices. Okay, after you have all prerequisites as a workflow, you will need also to grant access to Azure file resources, and first you will need to enable Azure AD authentication over SMB on the storage account. Assign access permission for a group or users that will access this share. Configure NTFS permission, and finally mount the share on the client station. It is important to mention that only one domain service can be used for file access authentication on the storage account, which applies to all file shares in the account. And a few benefits of Azure AD authentication, which actually seems obvious. It's allowing you to replace existing file servers without replacing your existing directory service, and assign new permission schema. A demo on how to access Azure files and authenticate via Azure AD will be presented over a few slides, where we will implement together Azure file shares. Well, cloud services continue to grow steadily, and some big companies have this challenge to migrate from on-premise infrastructure to the cloud, and challenges are reflected by the amount of data that needs to be transferred. Azure has a solution for this challenge: import-export service, that is used to securely import large amount of data to Azure Blob Storage and Azure files by shipping disk driver to an Azure data center. This service can also be used to transfer data from Azure Blob Storage to disk driver and ship to your on-premise sites. Basically, you can supply your own disk drivers and transfer data with the Azure Import-Export service, or use disk drivers supplied by Microsoft. You have two scenarios when Azure Import-Export service can help you: when uploading or downloading data over the network is too slow, or the costs are very big to get additional network bandwidth. Using this service, you can save time and money. In terms of security, you don't need to worry, because the data on drivers is encrypted using IS-256-bit BitLocker drive encryption. And the last aspect of this service, the price that will be applied for drive handling. There is a drive handling fee for each drive processed as part of your import or export job, shipping costs, and standard storage transaction charges applied during import as well as export of data. Okay, let's move to the next topic: Microsoft Azure Storage Explorer. It is a standalone application that makes it easy to work with Azure storage data on the most popular operating system like Windows, macOS, and Linux. It's an intuitive interface, and more important for us, it's free. With this tool, you easily manage Azure cloud storage resources for anywhere, easy to upload and download your data. The good part is that Storage Explorer will let you work disconnected from the cloud or offline with a local emulator. This is a big advantage of this tool. Basically, you can do almost anything on your local devices as in the Azure portal. What exactly looks like this application you will see in the next demo. So let's get familiar with Azure Storage Explorer. First, we'll download and install it, then use it to connect to Azure Storage accounts. As I said, it is a very simple and intuitive application. So here you have a local emulator account, and when a new account will be added, you will find it here under this tab. Below Account Management, an overview of your subscription and storage account added in this Storage Explorer. Next, from where you will add your storage account and a few settings. Now let's add a new storage account. You have a few options here: connection string, says, storage account keys, and other option. I will choose Azure account. After authentication, the subscription will appear here in Explorer. If you add the Azure account, of course all subscription will be added here, and also the storage accounts. And if we try to navigate under a storage account, you will see all storage services, and if you click right on one of the blob file, you have the option to open, download, change the access tier, generate a says, create a snapshot, almost the same option as in Azure portal. If you click right on the storage account as well, you have a few options to copy keys or change access tier. Hope this demo was useful. Thanks for watching, and let's move to the next topic. Another interesting tool that was developed by Azure is AZCopy, a command line utility that you can use to copy blobs or files to or from a storage account, also copy files between storage accounts and regions. In most cases, AZCopy can be run inside of a script that runs without user interaction, implement automation in your infrastructure, and so on. As you can see, this utility has a lot of features and capabilities that include a lot of options to satisfy your requirements. And some examples of how to use AZ utility. Actually, it's very simple as many other tools. Just use the source, destination, and parameters to copy data. Let's see how to work with AZCopy in the next demo. Okay, before using AZCopy utility, first download it and copy to system 32 folder. After that, we can start a PowerShell session. So the utility is very simple and intuitive as well. Use AZCopy, choose the source, we'll copy the URL from one of the blobs hosted on the storage account, and destination or a local path on your computer. As you can see, the file cannot be copied without using SS token. Let's get back to that blob and generate SS token. Now we will paste here as a source and should work. As you can see, one file has been transferred to a destination and the log file has been generated where you can check more detail about the entire process. So you have additional commands here that can be used to automate various processes when you use scripts. Thank you for watching, and let's move to the next topic. In this session, I have already mentioned that Azure Files offers fully managed file shares in the cloud that are accessible via SMB protocol. You can mount the shared link on Windows, macOS, and Linux. Azure File shares can also be replicated with Azure File Sync to Windows Server, either on-premise or in the cloud, for performance and distributed caching of the data where it is being used. With the recent release of Azure File AD Authentication, Azure File Share can continue to work with AD hosted on-premise for access control. Basically, this service was developed to completely replace or supplement traditional on-premise file share or NAS devices. Lift and shift application. What does it mean? This means that Azure Files make it easy to work in two scenarios. Classic, where both the application and its data are moved to Azure, and the hybrid, where the application data is moved to Azure Files and the application continues to run on-premise. Azure File Share can be deployed in two versions. We already discussed this: standard and premium version of storage account. Standard File Share is hosted on hard disk based and premium on solid state hardware. In terms of storage capacity, the standard file share can span up to 100 TB, and it's good to note that you have a good redundancy for this service. Let's enumerate a few advantages of Azure File Share. First, it's secure because the data is encrypted at rest and in transit using SMB 3.0 and HTTPS. Second, it's smart because you quickly access your files over high latency, low bandwidth links with smart caching of commonly used on-premise file using Azure File Sync. Cross-platform because you can mount your Azure File Share on Windows, Linux, or macOS. The most important is easily managed. You can deploy file share without having to manage hardware or operating system deployments. It's flexible because you can access your data from where you want to using SMB, REST, or even on-premise with Azure File Sync. Harmonious, easy migration to file share dependent application to the cloud. And as I promised, I will do a demo on how to deploy Azure File Shares. The objective of this demo is how to deploy Azure File Share. The first example will be a classic way where we'll create a file storage account, then we'll map the file share to a client. First step, we'll need to create a storage account with premium performance and the account kind file storage, and create it. I already have a storage account and will use file share service already presented on it. And the second step is to create the file share. You will need to give a name, add the quota. The quota is a file share size, and of course tiers: hot, cool, or transaction optimized. Once you have the file share, click connect to generate the script. Then you can execute in PowerShell and the disk will be added in an automatic way. So I use this script for Windows because the client is a Windows server. Open a PowerShell instance and paste the script. The script has the password, the storage account key, and as you can see, the disk was mounted. And if we create a few files here and refresh the file share in the portal, the documents as well will be presented here. So this is the classic way to add Azure file share drive to your client, but in some scenarios is not secure because the key used to map the drive could be compromised. So the best way is to use Azure AD credential to map the same folder. So as the first step, you will need to create Azure AD domain services. I already did this because the deployment is taking about 1 hour. Then we need to enable the storage account identity-based access for file shares as well. Already did this. On our storage accounts, this option is disabled. Okay, on the client side, the machine needs to be added to the domain. In the domain services that I have created about 2 hours ago, and as I said, until the domain services are not fully deployed, you will not be able to add the client to the domain. Also on the client side, you will need to add the Azure account that will do tasks on that drive. Hope I didn't skip any step in this process. Now when we want to connect on the same folder share, we will do this using the Azure AD credentials. So hope this quick demo helped you to understand how to set up a classic Azure file share and file share using Azure AD Authentication. So if you have any question related to this demo, don't hesitate to ask me via Facebook group that is presented in description of this video. Thank you. Already mentioned in the last slide that Azure File Share can be used in 2 ways: by directly mounting this serverless to the client, or by caching Azure File Share on-premise using Azure File Sync. Which deployment option you choose changes the aspects you need to consider as a plan for your deployment. Basically, Azure File Sync transforms Windows Server into a quick cache of your Azure File Share. You can use any protocol that's available on Windows Server to access your data locally, including SMB, NFS, or FTPS. You can have as many caches as you need across the world, depending on how many objects you have, offices, branches, and so on. There are 3 fundamental management objects for Azure File Sync. First is Azure File Share, that is a serverless cloud file share, which provides the cloud endpoint of a service sync relationship. You have server endpoint is a specific folder on a volume or the root of the volume. And sync group, the object that defines the sync relationship between a cloud endpoint or Azure File Share and the server endpoint. Let's go ahead with the next topic, Blob Storage service. I would like to add more info related to this service. Basically, Azure Blob Storage is optimized for storing massive amounts of unstructured data like documents, video, audio files, log, archives, and so on. Users or client applications can access objects in Blob Storage via HTTP or HTTPS. You already know this from the storage account overview slide. Blob Storage offers 3 types of resources: the storage account, a container in the storage account, a container can be associated as a folder, and blob in a container, and a blob can be associated as a file. The following diagram shows the relationship between these resources. To copy or move data from to Blob Storage, you will use tools that you already know, like AZCopy, Storage Explorer, and Azure Data Box for large datasets. And basically, this was the reason why the Blob Storage was presented now after the copy tools. So now you have a full picture of Azure Storage services, even if we have one more slide in front of us before ending this part. And the last subtopic from the second part, Azure Storage Services, it's about access tiers, which allows you to store blob object data in the most cost-effective manner. The available access tiers include hot, optimized for storing data that is accessed frequently; cool, optimized for storing data that is infrequently accessed and stored for at least 30 days; archive, optimized for storing data that is rarely accessed and stored for at least 180 days with flexible latency requirements on the order of hours. The archive access tier is applicable just on the blob level. You have probably noticed this thing when we have created a new storage account. The archive option was not available because you need to set this at blob level. Hot access tier has a higher storage cost than cool and archive, but the lowest access costs. Example usage scenarios could be the data that is in active use or expected to be accessed frequently. Cool access tier has lower storage cost and higher access costs compared to the hot storage. This tier is intended for data that will remain in cool tier for at least 30 days. An example could be short-term backups and disaster recovery datasets. Archive access tier has the lowest storage cost but higher data retrieval cost compared to the hot and cool tiers. Data must remain in the archive tier for at least 180 days or be subject to an early deletion charge. As an example could be long-term backups. And the last thing that I want to mention here, if the access tier is changed at account level, access tier applies to all access tier inherited objects stored in the account that don't have an explicit tier set. The access tier for a storage account can be seen in the account overview, and to change the blob access tier, navigate to Configuration tab, and here you will have two options, cool and hot. As I said, the archive option can be changed at blob level. Select the blob and click on Change Tier. In CLI as well, you can change the tier using set AZ storage account command and access tier parameter. For any question, don't hesitate to ask via Facebook group. The link is presented in the description of this video. Well, this is the end of the second part of this training. I would like to recap what you have learned. Basically, you have become familiar with how to implement and manage storage accounts, how to generate a SES token, the best way to work with the storage keys, replication options, manage data in Azure Storage, configure Azure files, and Azure Blob Storage. Again, if you have any question related to this part, the best way is to ask a question in the Facebook group. The link will be in the description of this video. The third part of this course will be about deploying and managing Azure compute resources. The link as well can be found in the description. If you found this video interesting, I am glad to receive a like and a share. And in general, if you like the content, you can subscribe and activate notification for new upcoming videos. I'm waiting for you in the next session. Thank you.